In this goal, we are going to be looking at molecular and empirical formulas. A molecular formula is the actual number and type of atoms in a substance. So it's the whole molecule. It's whatever there naturally, every single atom in that molecule. An empirical formula is a simplest formula, or it shows the element ratio. So let's look at our example right here. So we have C6H6. This is benzene. It's a ring of carbon with alternating double bonds. Each carbon has a hydrogen. So there's 6 carbons and 6 hydrogens. So that's what the molecule looks like. That is the molecular formula, C6H6. If I were to look for the element ratio, I could divide this by 6 and I would get CH. This is the empirical formula of benzene. So it shows the lowest ratio. It shows that there's a 1-to-1 ratio of carbon to hydrogen. So let's look at some more examples. So on the left-hand side, we'll have the molecular formula. On the right-hand side, we will write the empirical formula. So we've already done the first one. So again, divide by 6, and our lowest ratio is CH. Let's look at the next one. We have C2H2. I can also divide by 2, and this will give me a CH. Let's look at the next one. I see that a common number that I could divide through is also a 2, and I get CH2. This next one I would divide by 3. That would give me my lowest ratio, CH2. So there is a relationship with the empirical formula, or at least sometimes there are. There can be a relationship between molecules that have the same empirical formula. Let's look at the next one. We have dividing by 2, we get HO. So a 1-to-1 ratio of hydrogen to oxygen. And this next one, this is glucose divided by 6, and we get CH2O. So a 1-to-1 ratio of carbon and oxygen, and there are 2 hydrogens for every each one of those. What is the empirical formula for the next one? This one can be tricky. This one, the empirical formula and the molecular formula are exactly the same. This one is an ionic compound, and ionic compounds are large, solid, crystalline structures. And so when you write down their formulas, you are writing an empirical formula down. You're showing the lowest ratio. And we see in this one, because I only have 1 calcium, I can't divide it by 2. Because at first glance, it seems like you should be able to divide everything by 2, but you can't have half an atom, so it would be the same. So now we're going to use this empirical formula and what we learned last time with percent composition data. And given percent composition data, we will be able to write an empirical formula or the lowest ratio. So if given a percent, you will take that percent and you will convert it to grams. And how you do this is you assume that you have 100 grams because it makes your problem easier. So with 100 grams, if you have 32% of an element, you would have 32 grams of that element. You next will convert grams to moles, and then you'll find the ratio of moles by dividing through by the lowest number in that set. Let's look at this example. So around 40% carbon, 6.7% hydrogen, and 53% oxygen. Find the empirical formula. First thing I'm going to do is get rid of that percent because I can't really do anything with it. But I can do something with grams. So I'm assuming I have 100 grams of it. It doesn't tell us how much we have, and so I'm going to make my life easier and say I have 100 grams of it. We're going to take each of the gram amounts and we are going to convert them to moles. So with carbon, looking on the periodic table, there are 12 grams in 1 mole of carbon. And dividing through, I get 3.33 moles. Let's do the next one, 6.70 grams of hydrogen. Looking at your periodic table, there is 1 gram per 1 mole. This is the only time you'll ever see 1 gram being equal to 1 mole, only with hydrogen. And as I'm just multiplying, dividing by 1, I get the same number. And last but not least, we have our oxygen. And looking on the periodic table, 16 grams is equal to 1 mole of oxygen, and dividing through, I get 3.33 moles of my oxygen. Our next thing that for us to do is to look for the smallest number and divide through by that. My smallest number, it's the same number 2 times. So both carbon and oxygen have the smallest number of 3.33. So I'm going to divide everything by that number. So I get a 1 for here, and I get a 1 for here because we're dividing it by itself. And this one in the middle, I get on my calculator 2.01. This is close enough to a whole number. So we're looking for whole numbers. So you shouldn't have to round too much. It should be 1.99, or in this case, 2.01. This is the whole number 2. So this is not our final answer. Our final answer will be to write a formula. So how many carbons do I have? 1, because it tells me. How many hydrogens? 2. And how many oxygens? 1. This is my empirical formula, my answer. So in this example, we're not given our data in percent composition. Instead, it's already in grams. So they just made it easier for us. Start with the number that they give us in grams of each of the elements. So I have 21.5 grams of iron, and looking at the periodic table, I have 55.8 grams of iron in 1 mole. In dividing, I get 0.385 moles of iron. Let's look at our sulfur. So 18.5 grams of sulfur. And looking at the periodic table, I have 32.066 grams in 1 mole of sulfur. In dividing, I get 0.577 moles of sulfur. My next step is to divide through by the lowest number, and that would be the first one. So for iron, I have a ratio of 1, and for sulfur, I'll have a ratio of 1.5. Now, this is a halvesy, is what I call it. So the ratio is a 1 to 1.5 ratio, and you can't round this to 2. Instead, what you're going to do is multiply all the ratios through by 2. So my answer is Fe2S3 as my final answer. So don't round it up to 2. You're just, because it's a halvesy, you're going to double the whole thing. So in your homework, it should always be a whole number, or you might have one that has a halvesy in it. So, and if it's a whole number, it'll be really, really close. So like a 1.99, or maybe it's a 3.99 or 4. If you get something that's like 1.8 or 1.7 or 1.3, you have made a mistake. Another mistake that students have is they'll find their moles and they'll say, hey, I thought it was supposed to be a whole number, and instead I got these fractions. And that's because you need to divide through by the smallest number. So watch out for those, and good luck.